For problem number 4, we have a 10,000 kilogram helicopter lifts a 1,200 kilogram steel girder while accelerating upwards at 0.6 meters per second per second. A. What is the tension in the steel cable, assumed to be massless, supporting the girder? And B. What is the lift force exerted by the air on the propellers of the helicopter? Let's first watch the helicopter. The helicopter accelerates upwards at 0.6 meters per second, lifting the girder as it does so. The problem is to determine the tension in the cable between the helicopter and the girder, and also to determine the lift force exerted by the air on the propellers of the helicopter. Alright, that is the problem. Turn off your VCR now and try to solve that problem. Here is our all-important figure. M sub h represents the mass of the helicopter. It has a value of 10,000 kilograms. M sub s represents the mass of the steel girder. It has a value of 1,200 kilograms. Both helicopter and steel girder have an upward acceleration of 0.6 meters per second. In part A, we are asked to find the tension in the cable. If we look at the steel girder and draw a free body diagram on it, we would have the weight M sub s g acting downwards, the tension in the cable, call it T, acting upwards. And if we write Newton's second law for the girder, we would have T minus M sub s g is equal to M sub s a. Solving that for the tension T, that's equal to M sub s g plus M sub s a, or putting in their values, 1,200 kilograms multiplied by 9.8 meters per second plus 1,200 kilograms again times 0.6 meters per second. If you work that out on your calculator, you should find a total of 12,500 newtons if you round your answer to 3 significant figures. That then is the tension in the cable. In part B, we're asked for the lift on the helicopter. If we concentrate now on the helicopter and draw a free body diagram on it, we would have its weight downwards, M sub h times g. Also downwards we have the tension T. The same cable is attached to the helicopter as is attached to the steel girder. It is a massless cable, and the tension is the same everywhere. So the tension T is downwards on the helicopter. Also on the helicopter we have the lift upwards. Let's call that L. They are all the forces acting on the helicopter. Let's now write Newton's second law for the helicopter. We have the lift upwards, downwards, T, downwards, the weight must be equal to the mass of the helicopter times its acceleration. Solving for the lift L, we have that L then is equal to T plus M sub h g plus M sub h a. And putting in values for the tension T, we've already determined that that is 12,500 newtons plus the mass of the helicopter, 10,000 kilograms, multiplied by 9.8 meters per second plus the mass of the helicopter, 10,000 kilograms times 0.6 meters per second. I'll let you calculate that and confirm that to three significant figures. The answer that you get is 117,000 newtons. So that is the lift, the force of the air upwards on the propellers of the helicopter. That is the reaction to the force that the propellers exert downwards on the air. That is the solution then to our problem. Let us move on.